Hello everybody, welcome back. So I'm continuing to attempt to revive this old signal generator, and what I've achieved so far is to rise up the first stage of power supply. And if you've been watching my previous video, you have seen that I have also managed to repair a bit the chassis. So now I'm going to attempt to clean and repair if need, the regulator boards. So I will remove all this setup. Well, I of course still have to learn everything on this instrument, and I was mistaken when I thought that all the power supply are on continuously. Of course, it was very weird to me, and indeed the standby and on selector here, it's using the 22 volts that is in the rectifier board to drive the regulator boards and switch on the four power supplies that they regulate. So I already have cleaned and installed the positive regulator board, but is not driving the power transistor, since I have not connection with this switch. So at this point I need this, so I will go to repair and clean everything, and I will fit this in the instrument, so I will have the standby and on switch. Meanwhile, I was looking it, I found the small chunk of the connector that is missing here, so I will be able to put it back with super glue, so I will have the connector back complete. So I will go ahead with the cleaning. It will take some time and then I will be back. This is the current state, so I'm curious to see how it will be after the cleaning. Of course, I can't fix this problem, and I will just cover in the future with something, but I'm curious to see the final result. This is the front panel, and these are the buttons, and as you can see, they are very yellowed, and for sure would need of a retro bright, but weather doesn't help in this moment. So these are the wonderful dot matrix display, and here there are some ICs and some transistor that drives the lamps. This is the rotary pulse generator, the grandfather of encoders. Well, there is a bit of active components here, which make me change the mind, and instead of plug this board to power on the power supply, I will prepare a different, let's say, fixture in order to power the supply on. However, I will finish the reassembly of this and see the final result of front panel. This is the final result of the front panel. It's not perfect, of course. Here I have a crack that I had to glue with super glue, and there are some nasty signs here, but however I've been able to repair the line switch, and there is a an important information here that dated this instrument on June 1983. So it's close to 40 years old instrument. So I will put this aside and we will continue on the power supply. Well, I ended up with this setup. I have installed one resistor as a load for 20 volt. I have connected the electronic load for 5.2 volts. And I'm going to monitoring with these two multimeters the output voltage of both. And to fire it up, I'm using an external power supply to feed 20 volts in the input of the regulator board. So the instrument is already plugged in. I'm reading 36 millivolt on the plus 20 line. Don't know why. I'm trying to power it up. So 3, 2, 1, nothing. Okay, so need to be investigated more in depth. Well, I got it. I found the culprit, and I'll show you in a second. I'm going to switch on, and ta-da! 20 volts, 5.2, drawing 1 amps, or half an amps actually, but I can increase to 1 amp over there. And it was simply the replaced transistor. So this brand new transistor is not compatible with this and need the original one. Since the original has the shortened legs, I had to enlong them and I installed it inside, and now it's working. But believe me, I was lost. I have replaced almost everything in the plus 20 volts, and I did not find the culprit since I decided to use the original transistor. So I think now I can go ahead with the testing of the other board, the negative regulation board, but I need to replace also the other Darlington transistor that is not original. So I need to and lengthen the legs also on the other transistor. But look at this. We are having LED that are lighting here. I already have tested the over temperature switch off circuitry and is working fine. So from this point ahead, the road would be more clear. So hopefully the next birds will not give me the same difficulties to repair. So let's go ahead with the reassembly. Okay, another crazy setup. Monitoring all the outputs that there are from the two regulator boards. Positive and 3 negative voltages. Plus 20, plus 5.2, minus 10, if I'm not mistaken, minus 40 and minus 5.2. I'm going to fire it up. 3, 2, 1. Look at that. Spot on. Well, minus 5.2 is a bit low, but can you believe it? It's working. So this is pretty fine and allow me to make a step ahead. So I now can finish the repair of the broken PCB that connect the front panel to the instrument, and now I can go ahead with the fit of the front panel and try to switch on through the power button, and should be safe enough that the voltages are correct and doesn't damage any of the active components in the front panel. But this is a very good achievement, and for a so old instrument, I'm quite happy. So let's go ahead. With the power supplies up and running, it's time to try to repair this nasty crack, and after that I can plug this digital section contactor to the instrument and see if we can power it up from this. Well, as you can see, the extent of damage is quite high. It has been damaged the PCB here. There is a broken trace also on the other side, and the connector is cracked. One leg is broken and there are a few bits falling around. Will be not easy to fix this. Fortunately, I don't have any replacement with me, so it will be also not easy to find here. Well, let's go ahead and try to fix everything. Okay, I have reassembled the digital section case, the PCB repaired, and hopefully will give us some sign of life. Unfortunately, the standby bulb, it's broken, so I made this package, since without it we can't test the power supply. So let's go to test. Okay, now I will plug it in. If everything is fine, it should light up the bulb, and indeed it does, and the LED over there it's on. And if I flip this standby on switch, should change the state, and indeed it power up all the LED in the regulator boards. And I change a bit the camera. I've moved the camera so you can see the front display, and the bulb is on, and if I switch on, I'm having live signs in the display itself and also in the resolution buttons. Each of that are working fine, and that was the live signs that I was looking for. This will allow me to work on the digital section. So I also have done a bit of retro brighting on the power button here, not power button, sorry, for the keyboard buttons, and it works a bit, and has improved. The yellowing is disappeared a bit, but still to be done with the better setup. However, that's it for this video. In the next one, I will start to work with the digital board, and there are several boards actually, but first of all I need to install the frequency reference oscillator, 10 megahertz oscillator, which is the main frequency that move all the clocks inside the digital section. So first of all I will start from there. Thank you very much for watching, and please leave a comment and I will appreciate. So thank you very much for watching again, and see you soon.